I'm going to open the door. As you can see, the post request was sent immediately after disconnecting the sensor. Hi guys, before jumping into the code, let's talk a little bit about architecture of this project. In this case, Raspberry Pi is hosting my backend, my Flask server, and also is the trigger for GPIO signals. If GPIO state changes from high to low, it triggers external SMTP server, which is sending the email to desired recipient. There is a lot of free SMTP providers on the internet. We will set up account later, so don't worry about it. This approach is easy but has big drawback. If you are planning your system to be wireless, powered for example from a battery, Raspberry will draw probably over 200 milliamps, and that's a lot. And power efficient alternative is for example Arduino. In this case, the Flask server is moved to the cloud. You can utilize for example AWS for this task, but it requires additional configuration alongside with authentication, because cloud server cannot be open for everyone. One person with malicious intent can literally hack your IoT device, so be aware of that. So solution from this film is less efficient but safer for beginners. Okay, from the electronical and mechanical point of view, it looks like this. We have power bank. By the way, I did it by myself. If you want some details, check out my previous video. The Raspberry itself and the very primitive pull mechanism. Pulling the door is triggering this connection to pop. And now GPIO4 lost high state, and this event triggered SMTP server to send the email. I am using SMTP lib. It's probably shipped with a default Python installation. Flask and request you can install with just pip install command. Here is server initialization. These are SMTP credentials. I am using Elastic Email API, but there is plenty of them. I will put the link in the description. You have to set up an account, go to the settings and create SMTP credentials. I already did that. You have to copy and paste these 4 strings. Remember to put your sender email as a username. Next is the endpoint declaration /Arduino/door. Expected method is post. Here I am unpacking the body of the request and pass it to the body and the message of the email. Then SMTP initialization. Start TLS, where TLS stands for Transport Layer Security. It's for data encryption. Login, send email, and quit. Then return a string with successful message. But if some errors occur, we are returning message with the error stringified. And that's basically it for the server. Now let's talk about the trigger. This GPIO 0 library is available only for Raspberry platform, so on my macOS I can't install it. Here I arbitrarily chose digital pin 4. If you are using different board, check in datasheet which pins are available and are digital. This is my backend URL. By default, Flask runs on the port 5000. This pull-up argument is very important because it's pulling the pin low. In other words, the default state of this pin will be low. Is active is the Boolean property of this class, of this building class. Here is the loop which is triggering the post only when state changes from high to low. Tracking the previous state prevents from sending multiple requests when the doors are open. Additional exception for the keyboard interruption. And here I am passing current tie argument. Therefore, I know exactly when this event was triggered. And simple post request with trigger time payload. And at the end is helper function get current time, which I used here. Basically, it has very explicit name. It is returning formatted time, hour colon minutes colon seconds. Now I am going to connect to Raspberry via SSH and run the code. Both terminals are logged in Raspberry. On the right one I started the Flask server. It's called main.py because I have old version of the code on this Raspberry. If you pulled from my Git repository, it's probably called server.py. On the left one, let's run trigger.py. And now I am going to open the door. As you can see, the post request was sent immediately after disconnecting the sensor. And now we are waiting for SMTP. It usually takes 20, maybe 30 seconds. It works perfect. I received email with slight delay, but as I planned, this email is shipped with exact trigger time. So even if I receive the email with big delay, let's say 15 minutes, still I will know exactly when this door were open with 1 second precision. Keep in mind that it's just a proof of concept, not ready for real world applications, but this idea can be extended to get data from temperature sensor, water sensor, or even DC motors. Okay, that's it for today. Thanks for watching and see you soon.